everyone. Hello and welcome to Puro Earth webinar about geologically stored carbon removals, the methodology revision. We are still waiting for a minute or two to let people join. So please take your seats and be prepared. We are recording this meeting. And you should see the questions and answers section at the bottom of your screen. So use that when you want to place a question. So let's then get started. 2 minutes past the hour. Welcome everybody. My name is Marianne Tikkanen, head of Puro Standard, and this webinar is about geologically stored carbon methodology under the Puro Standard, which is now being revised and open for public consultation. So warmly welcome everybody to this webinar, and on the agenda we have the Puro team presenters. Then they will walk through the key areas of the methodology, and then we open the floor for questions. For your questions, please use the Q&A button at the bottom of your Zoom screen, and or then you can ask to speak, and then state your name and company when you tell the question. So let's get started. Richard, if you present yourself, and Elias.
Hello everyone, my name is Richard. I'm a scientific advisor here at Puro, and I am in the team that wrote the actual revision of the methodology, and here today with me are my colleagues from the Puro scientific team, and most importantly, of course, my co-speaker here today, Elias Atsi, who is also a scientific and LCA advisor here.
I don't have much to add compared to what Richard says, but welcome everyone again. And indeed, we've been working together on that methodology update, which we will present today, the main elements.
All right, so without further ado, let's get started. So the idea here is that we have a short presentation of the most salient points of the update, but the bulk of this webinar will be reserved for your questions and answers. So we hope intense participation in the form of lots of questions. So the agenda we already covered, introduction, then this presentation, and the questions and answers that will follow. So let's start to look at what has changed and how. So like all Puro Earth methodologies, the geologically stored carbon methodology is focused on carbon removals. So we do not want to credit pure mitigation activities where, say, fossil fuels are extracted from the earth and then later returned to the same geological reservoir. We actually want to reduce the amount of carbon dioxide in the atmosphere by means of either direct air capture or then biogenic CCS. So clear focus on removals. Now, this particular methodology focuses on injection of carbon dioxide into the Earth's crust. So that can take place through several pathways. So this methodology covers two sort of like two major pathways, which are then divided into several variants depending on, say, the capture type. So this methodology covers the injection of either pure CO2 or injection of CO2 dissolved in water into deep geological reservoirs, which can be things like saline aquifers or, say, depleted hydrocarbon reservoirs, things like that. Now the CO2 itself can also come from various sources, so it can come directly from the atmosphere through direct air capture, but it can also come from processing eligible sustainably sourced biomass, most importantly perhaps through BECCS, bioenergy and with carbon capture and storage, but also from other industrial processes like fermentation with associated capture of CO2, or then waste incineration with capture of CO2. But importantly, we only credit biogenic CO2 that is pumped underground. So, for example, in waste plus CCS, only the biogenic portion of the CO2 would be credited. This methodology aims and ensures sort of safe and permanent carbon removal. So that's on a long 1,000-year time scale that the CO2 must remain underground, and it is confined to regions with a already existing robust legal framework for geological storage. So things like requirements for storage permits are must already be in place. This methodology also includes quite strict requirements for monitoring environmental and social safeguards, carbon accounting, and all of the sort of various important aspects in geological storage. Now, in geologically stored carbon, the permanence and storage security is ensured by several chemical and physical sort of barriers for re-emission. These can be things like CO2 being physically trapped under a low permeability cap rock, but it can also be in terms of chemical trapping, such as transformation of CO2 into solid mineral carbonates that will remain for geological timescales, like millions of years in the bedrock. Now, since this is actually an update of a previous methodology, let's look at what all has changed. So overall, this methodology has changed quite a bit, and it is now significantly longer than the current one, and includes a complete sort of overhaul of all sections of the methodology and several important key details. So the most sort of salient points are listed here, and there are some important restrictions compared to the previous or the current version of the methodology. So most importantly, this methodology no longer allows the injection of carbon-containing substances such as bio-oils or slurries, but only pure CO2, or then this pure CO2 dissolved in water. And it also does not allow enhanced oil recovery or then enhanced hydrocarbon recovery in general. So enhanced oil recovery or enhanced recovery of coal with methane. So and these requirements stems from ICVCM requirements forbidding basically activities that support fossil fuel extraction. This methodology also has several new sections compared to the previous one. So it now distinguishes several sort of baseline scenarios, i.e. what would have happened sort of without the project, and then the emission accounting associated with said baseline requirements. And it also quantifies leakage, and that is now both in the sense of physical leakage from from the storage reservoir, but also in terms of indirect leakage, so emissions resulting from the project but not directly included in the activity boundary, like activity shifting leakage. The rules for quantifying CORCs have been revised and simplified, and as have sustainability criteria for biomass eligibility have been significantly revised, and also this methodology public consultation draft comes with a separate addendum on biomass sustainability criteria that are then envisioned to later be applicable across Puro standards, but are now released in the context of this methodology to start with. Also, importantly, practices for monitoring practices and data collecting, as well as risk assessment and management, have been significantly updated as well. Now, this methodology aims for a very comprehensive carbon accounting. So the amount of carbon credits that a project would receive is the net amount of carbon stored. So from the actual CO2 that you pump underground, various deductions are made. Most importantly, greenhouse gas emissions that you emit during the capture, transport, and storage activities, and any leakage, like physical leakage that would possibly occur from the storage reservoir, say if the reservoir or wells malfunction, or if there's a leak, but also then emissions due to unmitigated negative ecological and market and activity shifting leakage. So these are emissions that are created because of your project, but outside the direct activity boundary. These are all detailed in their own sections of the methodology that you can see here. So as you can see, they are quite the LCA accounting and leakage are quite comprehensively tackled. They each get their own sections in the methodology. And now I'd like to hand over to my colleague Elias, who will talk a little bit more about greenhouse gas accounting in this methodology.
Yes, indeed. So from this master equation that you have on the screen, it's important to understand that each term has its own sub-equations and rules that apply to them. And when it comes to supply chain emissions, we have an entire chapter that defines how to actually do the life cycle assessment, what to include and how to include it. And a good summary that we have in this methodology now is this table that splits all the supply chain emissions from a BECCS or DACS project into 3 steps, which we call the capture step, the transport, and the injection step. And basically, if we summarize the methodology, for all these 3 steps, the projects will have to be able to calculate both their operational emissions from the carbon capture, carbon transport, and storage, as well as embodied emissions from all type of infrastructure, construction and maintenance, yes, and also direct land use change emissions when infrastructures is being set up. Also, what is shown in this table, and that we believe is rather important, is that the results of an LCA must not be provided as a single number, but they must be disclosed in different contributions so that there is more transparency into how those calculations have been performed. And more specifically, the contributions here that are marked with the little asterisks are even meant to be publicly disclosed in the Puro registry once a project has been audited and certified. If we move on to the next slide, another novelty with this methodology update is that we now have explicit biomass sourcing criteria, which now applies or will apply for bio-CCS projects, but will, in the future, as Richard has mentioned, will also be applied to other methodologies that are based on biomass. And these biomass sourcing criteria distinguish between 15 categories of biomass feedstocks. Some of them are traditionally perceived as waste feedstocks of different kinds, but then we also have agricultural residues of different sources, and also forest biomass, for instance. And for each of these categories, these new rules for biomass sourcing are defining criteria that must be evidenced by the projects. Criteria in terms of traceability of the biomass, so defining its origin and its type and demonstrating from where it's been sourced, but also criteria in terms of sustainability of its production. And of course, the criteria will be different depending on what type of biomass is tackled. And that's because the ecosystems in which those biomass are produced are not exposed to the same risk and challenges. And also important to mention here is that we foresee that the way to demonstrate the sustainability of a given biomass feedstock and the traceability will not be possible only in one way, but there will be multiple options to demonstrate criteria. And if I take the example of forest biomass, previously within Puro, we only had the certification or regulatory compliance that were options to demonstrate sustainability of the biomass feedstock. Here, we also expanded and diversify the ways of demonstrating compliance. And that is then explained in this separate appendix that is appendix to this methodology. Yes, and as said earlier, we foresee that these biomass sourcing criteria will also be valid for most all other biomass or carbon removal pathways that are based on biomass. Yes.
Right. So thanks for listening. So this is the sort of extent of our introduction, and now we'd like to move into the sort of question and answer section, and to answer any questions and concerns that you might have surrounding this methodology.
I will now, we have received questions here in Q&A. Thank you for using that, and keep using that. So we will pick questions from there. Let's start with, there were two questions related to emission factors and LCA matters here. There was one here from Wenxing Zhang. If the emission factor of a renewable energy can be calculated as a zero. Elias, I think this is your area.
Yes, so whenever renewable energy such as wind power or solar photovoltaic electricity is used, no, it cannot be simplified as zero. The full supply chain emissions and thereby included embodied emissions must be recorded or included in the LCA. But then I see that the question from Shannon Gray is a bit more specific and is asking about even for how long those embodied emissions have to be allocated for. And there I would say that in the general case, when we rely on emission factors for wind and solar, there are default assumptions being made regarding the lifetime of a PV or wind power installation, and that is fine to use. But there might be exception to this, which is when the renewable energy farm is specifically installed on-site, co-located, for instance, with the removal activity, and there may be a different rule would apply, and that would be then the rule that is in the methodology, which we call the 10-year period.
Yeah, but would you say, Elias, that normally they are not zero, even if they are close to zero?
Yeah, but they are never set to zero, that's for sure.
Okay,
They're
thank
always
you.
positive number.
There was another one related to this type of LCA or looking at the project emissions from Shannon Gray. Does the methodology include emissions for renewable energy? Are these emissions allocated over the project life or 10-year? Sorry, embodied emissions related to renewable energy? And are these allocated over the 10-year period? Maybe you can cover, Elias, the embodied emissions, not only for the renewable energy, but also for the project itself.
So I think I partly answered that question already here, but so yes, again, renewable energy has to be accounted as non-zero, and the non-zero comes from embodied emissions. So whenever the embodied emissions take place in the foreground system of your LCA, so when it's directly you who are building that infrastructure, then we have this 10-year rule that applies. But whenever it's embodied emissions that come from your background system, let's say when you're sourcing electricity from a grid, and that contains renewable electricity, then we rely on default emission factors where usually the lifetime would be the project life and not the 10-year period.
Thank you. Then Richard, about the permitting of the storage sites. There is a Canadian question and a Chinese question. A question from Shannon Gray. Were the Canadian protocols and regulation reviewed or considered for being approved under the method for CCS?
Yes. Certainly considered. The Canadian regulation were not as extensively reviewed as EU and US regulation, but we are well aware that Canada has very has good regulation in place for CCS regulation, and this is a question that we actually included in the sort of public consultation questionnaire. One of the questions is that should other countries be included in this methodology, so if a priori approved regions, and we have also discussed this amongst the working group. So we are certainly considering to add Canada to that list, but we'll start off. We didn't include it in this draft because we wanted to collect some more feedback from the general public on this topic.
So Shannon, it may be a good feedback from you to then give that through the public consultation. The Chinese question about the same thing was that China does not currently have legal framework especially designed for permanent storage of carbon dioxide. In this case, would a project from China be able to register in Puro?
Well, if there is no such regulation in place, then the answer would be no, since it does not fulfill the requirement in the methodology. But the sort of detailed answer to that would need to come from a sort of study of then what regulations are in place and can they answer to the requirements of the methodology. But if there is if there's just plain no regulation about that, then no, a project such as that would not be eligible under that methodology.
Thank you. Then there was, Richard, a question to you about the purity of CO2 stream. Now there is the requirement of 95% concentration, and this question is related to waste to energy plants where the wording currently has to be 95% CO2 from an eligible CO2 source, where that might not be the case in case of waste to energy. So would that be possible?
No, that I mean, that doesn't. It's not intended to be like that. So the 95% purity from an eligible source means basically that what you pump in the reservoir must be sort of pure, nearly pure CO2, but it doesn't mean that it has to be purely from an eligible source. You can pump other CO2 in there as well. It refers to the sort of purity of the CO2. So in case of waste to CCS, it means that you have to purify the flue gas so that it contains overwhelmingly CO2, but it doesn't mean that it can only contain up to 5% fossil CO2. That might necessitate some clarification in the methodology, but that's not the intention of the rule.
Yeah, thank you, Richard. So that wording may be made clearer. Then Elias, a question about the amortization, the 10-year rule, why was 10 years selected for the maximum amortization period for the embodied emissions from the project and construction and equipment?
So indeed, 10 years can sound as an arbitrary number, but we had considered that to be a reasonable and rather conservative duration, in line also with the crediting periods that we were considering to be around 10 years as well in that methodology. And in that way, we are on a conservative side, but of course, once a 10-year period will be complete, and if the project is still eligible to issue credits, then for the subsequent years, there will not be any embodied emissions anymore to report, except for maintenance that might be ongoing or repairs that have to occur. Yeah.
Thanks. Then Richard, what do you think about the GSC risks, leakage, reversal, microseismicity, and others, and their implications on the quality of carbon credits? Your system seems to be binary. This is a question from Andres Rojo.
Yes, so in general, the sort of main risks that pop up in the sort of literature and conversation are indeed what if the storage reservoir leaks, or then what if there's like groundwater contamination following leaks, or then indeed induced seismicity is often a problem. So leaking of the reservoir in case of deep geological storage is very rare. So we have sort of opinions from the IPCC saying that basically CO2 injected into a geological storage reservoir is essentially permanent, but note that this is in the case of a well-managed sort of site and well-managed in a sort of region where proper regulation is in place. And also there have been numerical simulations and studies, for example, on different well permeable or like different leakage probabilities depending on, say, the condition and type of existing wells or transmissive faults or fractures, and the overwhelming majority of the evidence in the scientific literature suggests that leaking from the geological storage reservoir to the atmosphere should be very, very small, like negligible in the context of a well-managed site and well-managed sort of regulation. And that's why we have also this requirement for a region with a robust legal framework surrounding the injection or CCS activities. And one about induced seismicity. So indeed, seismic events in the context of injecting something underground is well established. So and those seismic activity has been detected in the context of CCS project as well. But the overwhelming majority of those seismic events have been limited to micro seismic events. So that would be seismic events so minor that they are not felt by humans on the surface of the Earth, but can be recorded by accurate seismic measuring devices. So thus far, seismic events have not been a problem with CCS, carbon dioxide storage projects, although there have been some minor seismic events that have been sort of just large enough to be felt and might cause a sort of nuisance to the local population. Those have been indeed detected in some cases, but they are quite rare to be sort of large enough to cause any nuisance, and there have not really been any seismic events large enough to cause sort of like major problems with the storage reservoir. So yes, it is indeed a risk, but also there is quite sort of mature field surrounding seismic hazard assessment and management. Of course, that is mostly in the context of natural seismic events, but there's at least a sort of good basis to assess and manage risks with seismic events.
Thank you. And thank you for sending your questions to the Q&A. We will eventually answer all of those. Those who have anonymous there, please repost your question with your name. I will not pick the anonymous questions here live. And if some questions are unanswered when we finish, we will then give the written answers to those. But next question is about the amount of information that is expected and publicly disclosed. There is a question, is it your view that all of these values are strictly necessary to disclose? The numbers could be further aggregated instead of providing detailed breakdown. Elias, would you take this?
Yes, so indeed there is a trade-off here between complete transparency that is sometimes required by ICVCM, for instance, a voluntary standard for carbon removal, and then of course sensitive information from a commercial and technical perspective. We believe that at the moment what is suggested in the methodology is at a sufficient level of transparency, in the sense that we are asking to disclose between operational and embodied emissions, but then within operational emissions, it is not required to make public the individual sources of energy use, material use, and so on. So all of that is aggregated into operational emissions. Of course, projects have the freedom to disclose more information if they wish, but we think that this minimum of aggregating at operational versus embodied should be feasible. And from discussion with other projects during the working group sessions and in other bilateral discussions, it seemed to be a feasible level. But if you differ, please send your feedback and motivation via the public consultation forum, and then we will, of course, can still take that into consideration.
Yeah, and you should now have the link in the chat to that public consultation invitation and the forms and the documents that you can download from there. So yes, there is a level of detail that you have to deliver to us and the verifiers, but then another level of detail that is then disclosed and public. Next, Richard, there is a question about why the carbon-containing compounds have been excluded. Is there evidence to suggest that this is less permanent than liquid CO2 storage?
Well, the main reason for that exclusion was not really related to the permanence of injected liquids underground, but rather the different types of requirements that would be needed to address the sort of very different characters or characteristics of an injected carbon-containing liquid in general versus injection of pure CO2. So there is plenty of evidence to suggest or to show that even impurities in the CO2 stream can affect the physical and chemical behavior of CO2 underground, then let alone the injected material being something completely different than CO2, like a CO2 containing liquid. We are not saying that we don't believe that an injection of CO2 containing liquids underground would be like a bad thing to do for the climate. We're just saying that it does not really fit into the same methodology as injection of pure CO2.
Thank you, Richard. So it's not the same phenomenon. In Puro standard, we have focused on the storage. So if the storage type and phenomenon are the same, how is the carbon maintained in the storage, then they belong to the same methodology. Elias, there is a question about sustainability criteria. Can you elaborate on that? What are the sustainability criteria for biomass if biomass is the interim step for capturing CO2 from the atmosphere?
Yes, so the document is an appendix because it's quite long, and so here we have about 12 pages of criteria that are different for each feedstock. But if I give an example, let's say the example of forest biomass, the criteria that need to be demonstrated tackle both social and environmental aspects, such as legal operation for the forest activities, good working conditions, systematic replanting of the forest stocks, maintenance of or improvement of carbon stocks, adequate management of soil to preserve its quality, similar criteria for water resources, air quality, biodiversity in the forest stands, and then also consideration of indigenous populations and local needs, as well as the protection of high-value ecosystems, which includes non-harvesting from primary forest, high biodiversity areas, and high carbon stock land use. So there are quite a lot of them, and each of them is explained in this appendix document. And so what I listed now is what we have for forest, but we have similar things for other types of biomass.
And maybe you can continue that, Elias. There is a question about, could you say more about the criteria for traceability of biomass, such as residual waste? So if we move to waste area, what are those requirements?
So generally speaking, for waste feedstocks, and waste feedstocks are the ones that we define here in this appendix. The traceability and the sustainability criteria are usually less strict than for forest biomass or other cultivated biomass. And in terms of traceability for, let's say, food waste from an urban area, the minimum information we would require would be the geographical area of supply and the name of the entities that have been delivering the waste to the processing factory. And that is in contrast to, let's say palm oil topics, where then we will have to go much more detailed and deeper in the traceability up to the field where the biomass was harvested.
Thank you, Elias. Then maybe Richard, next question from Andres Fernandez. Interested to learn more about the monitoring mechanisms that you are envisioning to quantify reversals, and what are the ways that Puro Earth considers variability in performance in injection of CO2?
Yeah, yes. Indeed, an important aspect of monitoring the storage site is to check for whether CO2 actually stays in the underground. Now there are several different sort of methods to monitor a CCS sort of project in general. So this would be perhaps most importantly down deep surface monitoring. So things like different kinds of wireline or other logs that are like, for example, temperature or pressure gauges in the actual wellbore, or then other types of measurements such as like acoustic velocity or resistivity. But besides that, there are other measurements that can and should be done as well. So given that a typical sort of site affected is quite large, so purely relying on direct sampling, say from wellbores, might not be that efficient to discover sort of like small sources of leaks that are not easily detected, say by pressure monitoring in the wellbore. So this could be various types of remote sensing, for example, through aerial or satellite data. So, for example, hyperspectral imaging, or then publicly available spectral data. Of course, this would then be usually with contracted equipment. So we of course don't expect people to launch their own satellites or anything like that. But and besides that, there are various ways of sort of other types of remote sensing, such as sensing temperature anomalies, vegetative stress, then changes in sort of shape or elevation and shape of the ground, that can be used as sort of indirect measurements, in the sense that while they don't necessarily tell you exactly how much CO2 is leaking, they are usually useful in locating sources of like previously unknown sources of leaks, and then you can actually go down there in that specific spot and take measure like more accurate measurements. So what's important here is that all projects must choose a suite of measuring technologies that take into account the site-specific characteristics. So the methodology does require several types of measurements to be performed at regular intervals. And also, of course, there are always the backbone of the local regulation. So only such regions are allowed where there is actually some regulation on monitoring practices as well. And the methodology also gives a host of sort of guidance on what is good practice in monitoring CCS activities.
Thank you. Then there is a commercial question, which I can take here. What is the status of the methodology, and can it be freely used outside of commercial purposes for reporting in geographies where the regulation do not allow carbon credits generation? You can use this internally or non-commercially to advise your project design and project implementation, project planning. But commercial use of it does require, commercial and public use of it does require you to be member and have a contract with Puro Earth, so that that is the commercial framework where the use of the methodologies happen. Then there was a question about an LCA study. Does the LCA study submitted to Puro require independent third-party review before the auditing process?
No, this is not something we required Puro us, that this LCAs should be reviewed following the ISO process. No, it's not a requirement.
Okay, so the follow-up question was, can the LCA also be developed by internal LCA team if the project has an internal LCA team?
Yes, it can be, provided that it meets all the transparency and technical requirements defined in the methodology, and that it also follows the templates that are being provided by Puro.
And then we have a person who would like to ask his question, Graham Hawkins. If you can give Graham Hawkins right to speak, Elba, then we can take your question, Graham. Can you unmute Graham? Yes. And if you would like to put on your camera and tell from which company you are coming from.
Okay. Hi there. I don't know if everybody can hear me, but yeah, I'm Graham. I'm trying to figure out where to find my camera.
Okay, but we can hear you. That's
you can hear me.
Start.
Okay, that's good. But well, I'm from Charles Taylor Environmental Adjusting, so I see it from the environmental pollution and impact to biodiversity that the insurance market look at. So some of my insurer clients are looking to support the carbon capture projects to provide them with the necessary insurance cover. And I was really looking at how they perceive that what problems do you think could arise from the carbon capture if the containment fails? Just to give me an idea of what I may be facing.
Well, if the containment fails, there's then the obvious problem that carbon dioxide will move to a section or in a location where it is not wanted. So carbon dioxide can leak directly to the atmosphere. For example, if there is a improperly sealed legacy well connected with the storage reservoir. So in that case, it would be a leak directly to the atmosphere. Now, given that these even abandoned wells are usually not, left completely open, but they are always sealed. But of course, sealing might conceivably leak. So this would be a rather sort of small leak to the atmosphere, not in the sense that not the type really that would result in a major catastrophe with people dying from the CO2 or anything like that. But then there are also other types of leaks that might occur, even if CO2 does not reach the atmosphere itself. If it leaks from the storage reservoir, it might encounter, for example, a source of underground drinking water. And if either CO2 or then other sort of formation fluids such as brine leak into underground sources of drinking water, then that might cause problems. So change in pH following CO2 dissolution in drinking water might cause harmful heavy metals to be leached from the sort of reservoir rock into the water, or then brine might sort of contaminate the water source and make it sort of undrinkable. And then
No, that's great. That gives me a lot to think about. Thank you. Thank you very much.
Yeah.
Thank you. Maybe we wanted to reserve plenty of time for questions and answers, but there are plenty questions. So I think we will not be able to cover all of those in this meeting, but we will then cover them afterwards in writing. I want to remind you that please do send your feedback, especially focused on how you see that the methodology should be still revised in the wording now that it is not yet in its final form. So the form to send that feedback to the methodology document is there in your chat and in our webpage for public consultations. One more scoping question. So the scope was changed from previous version to this version. We already discussed one of the scope changes being the carbon containing compounds, which are now excluded. Here is a question about why is EOR, enhanced oil recovery, now excluded? Why did you change from the previous version of the methodology?
Well, it's basically because we want to align with the ICVCM core carbon principles that specifically prohibit removal methodologies that support basically enhanced oil recovery or that type of activities that lead to increased extraction of fossil fuels from the earth.
Okay, so the core carbon principles, the ICVCM quality standard is the reason behind, or one of the reasons behind that. Then for final question, how will the project monitor for reversals of sequestered carbon to the atmosphere? Reversals as when carbon that is stored by a project is released into the atmosphere by either avoidable or unavoidable events. So I assume that this question is about reversals when the carbon has already been securely stored in the containment or the storage.
Yes, right. So as to how it will be done, as in what devices, I already talked about that in my previous answer. But there is as to how it is sort of quantified in the methodology. There is rules in the methodology that the supplier must monitor for these release events, and in case they are detected, they must be quantified and reported, but there's further sort of requirements that if a release event is detected, the CO2 removal supplier must immediately undertake sort of appropriate action to limit the damage, notify the issuing bodies, so that is Puro Earth, and then quantify the amount, and that will be then deducted from the carbon credits that will be issued. Now, of course, in some cases there are intentional releases, such as in the case where small amounts of, say, reservoir fluids are pumped back to the surface for monitoring purposes without reinjection, or then venting CO2, for example, from overpressure valves for safety reasons and things like that. So these must also be accounted for and deducted from the carbon credits. So all of these events must be sort of thoroughly recorded and quantified. Then either through direct measurements, or then using sort of conservative estimates based on, say, the flux of CO2, measured flux of CO2, and estimated time that the leak has been sort of ongoing.
Thank you, Richard. And the obligation to compensate for those is always with the CO2 removal supplier, which is the project. But that was our final question in this webinar. Thank you very much for everybody for joining. We expect your feedback to the revised methodology through the form and by reading the invitation and the documents where the link is in the chat, and those are also published in our web page under public consultations. The timeline of this after public consultation, which is now open until almost end of April, then we will take all that feedback, consider it, and make the final edits to the methodology, after which it will go to our independent advisory board, and then be released as a new approved methodology for this type of geologically stored carbon, whether it's captured directly from air or through biomass, through the different forms of biomass or waste incineration. So warm thanks for participating, and hope to receive plenty of feedback.
Thank you everyone for participating, and I had a great time answering all of your questions, and happy to see such vibrant participation.